everyone, so today my plan of attack is to just talk through how do we complete the square, because once you get it, it's a pretty nice concept. There's just a nice process you can follow, but it is a little bit complex when you start. So first of all, why would we even complete the square? Well, when you go into graphic arts, a lot of times you'll use circles or something called ellipses, which are like ovals, or hyperbolas, parabolas, all sorts of things like that. And as you're writing those equations, completing the square becomes an important piece of that and how to write the program for that. So that's kind of the backstory of why we would do it. And so now we're just going to work on doing that. So the process is this. My ultimate goal is to solve the question. But my middle goal is always going to get to be something squared equals a number. Like that's my process of where I'm going. So how do I get there? There's a bunch of different ways you can do it. Here's my process that I like best. So what I would do is I start off here and I've got an x squared plus 6x minus 7 equals 0. Well, I need to complete the square, and so in order to do that, this minus 7 is kind of in the way, and I don't want to use that for now. So what I'm going to do, I'm just going to move that over to the other side for right now. So that gives me x squared plus 6x. And then when I complete the square, what's going to happen is I'm going to end up with plus something here. It will always be plus something. And then over on this side, I now have 7. But think about a teeter-totter. If you have a little teeter-totter over here, if you have a little person here standing on it, not being very safe, and you have a little person over here, so it's equally balanced right now. However, then if I come and put a new person right here, well then this side goes down and this guy goes flying. And that is not a good thing. So in order for that not to happen, I have to do the same thing to both sides. So if I add something to this side, I have to add it to this side. So now what's my process from there? Well, I said that we were going to, our ultimate goal, or like our middle goal, was to end up with x and something squared. So I'm just going to put the x here, and then I'm going to figure out, okay, if I was going to square something, what would I do? And I'm going to pick plus 3. Why in the world did I pick plus 3? Well, it all came from right here. When I'm doing a square, in order to get 6 in the middle, I need to have 3, because 3 doubled gives me 6. Okay, so what I did, I took this 6, I cut it in half, and that gave me 3, which I put right here. But now I'm kind of working between two lines at a time, because if I did x plus 3 and I squared that, I'm just going to take a little thought bubble over here and take, so x plus 3 all squared. What happens when I do that? Well, x times x gives me x squared, then plot right here plus 3x, and I would get a second plus 3x, so I get plus 6x in the middle. What do we get at the end? I get plus 9. That's what happens when I do this x plus 3. So therefore, I go up here, that 3 squared becomes a 9. Now come back to my example over here. If I add 9 to one side, I have to add it to the other side so nobody gets hurt. So now what I have is x plus 3 all squared plus 7 and 9 makes 16. Oh my gosh, this is a really nice one. Usually they don't turn out this nice, but in this case they do. So I have now completed the square, but now I need to solve for it because that is the next piece in what it's going to ask. So if I'm going to solve for that, how do I undo x plus 3 all squared? Well, I square root it over here. So I get x plus 3. However, a quick thought, when you're solving for an x and you take the square root of 16, there's two solutions. always. Because you could have positive 4, but you could also have negative 4. So over here I get plus or minus 4. So that means I'm going to have 2 solutions. And I'm actually going to take, see this plus and minus 4? I'm going to take, and I'm going to write over here, I'm going to make an equal sign in this and move the negative 4 over here, just so that I see that I get 2 solutions. Okay, now I go through, minus 3, minus 3, minus 3, I have to do it to all the places. So x could be 1, but it could also be negative 7. So let's check that out. Well, if I plugged negative 7 back in here, negative 7 plus 3 gives me negative 4. Negative 4 squared is 16. Yep. If I plugged in 1 right there, 1 plus 3 is 4. 4 squared is 16. Yep, it works. So I got 2 answers, negative 7 and 1. Okay, let's try another one. I will walk you through it, but maybe you just want to say, hey, I want to try it on my own. I think I see the process. Great, then push pause and come back to it. All right, here we go. I want to solve it by completing the square. So the ultimate goal is to solve, but the pre-ultimate goal is to complete the square. So I want this part right here, but this minus 2 is not helpful to me right now. So I'm going to move it over to the other side. Okay, so now I have x squared minus 2x plus something. How do I know it's going to be plus? Because whenever you square something that is an integer, you get a positive. We're not working with imaginary numbers right now. We're just working with integers. So I'm going to add something over here equals 2, and I have to add this something to that side as well. So now I know that I'm going to end up with something squared equals 2 plus something. So I know it's going to be x. How do I figure out what goes here? Well, I look in here, and I see this is minus 2. So I cut minus 2 in half, you get minus 1. And that's just because of how it works when you square things. The pattern is you double, when I'm squaring, you double negative 1x, and negative 1x gives you negative 2x. Okay, now I have to go back up. I'm working 2 lines at a time. Negative 1 squared equals 1. If I add 1 to the left side, got to add 1 to the right side, so I get 3. Ooh, this one is not going to come out as pretty because there's not a perfect square of 3. But that's okay. Welcome to algebra. So, in order to undo squared, I square root both sides. And so I get x minus 1 equals positive square root of 3 or negative square root of 3. Don't forget the plus or minus. I'm just putting it on either side so it's easier for me to solve. Then I add 1, add 1, add 1. So my ultimate answer is 1 minus root 3 equals x, which equals, x could also equal 1 plus square root of 3. Now you might say, hey, couldn't I just write that as 1 plus or minus the square root of 3? Yep, you totally could. As long as you see that that is 2 different solutions. We got it. Or just leave it right here. Okay, one more. Pause it and try it yourself. And then I'm going to talk through it super fast. So pause. All right, you're back. So plus 11, plus 11. I think I wrote down the answer. I think it's going to be 3 plus or minus 2 root 5. So did you get that? If you did, you don't have to watch anymore. If you didn't, either I wrote down the wrong answer or you did it wrong. So let's check. So x squared minus 6x plus blank equals 11 plus blank. Okay, then I come down into my x something squared equals something. Okay, I look at this, negative 6. Negative 6, cut that in half because that's just what the pattern is. Minus 3. Okay, so this minus 3 here, if I square that, I get plus 9. So I add 9 to both sides. Over here I get 20. Now what do we do? Now I want to square root both sides. And square root this side, so I get, yep, this is going to work, x minus 3 equals plus or minus 2 root 5. Why is it 2 root 5? Because 20 breaks down into 4 times 5, so square root gives you 2 root 5. So then I add my 3 plus 3, so I get x equals 3 plus or minus 2 root 5. Okay, now if you're like, hey Beaver, why last time did you put the negative over here? Okay, you totally still could do that. And then you'd end up with 3 minus 2 root 5. And on this side, you'd end up with 3 plus 2 root 5. It's the same, you get the same answer either way. So there's just a quick tutorial how to complete the square if you're living in my brain. Hope that helps.